Hello everyone. Today we are going to find all natural numbers mn such that the sum of first m natural numbers is equal the sum of next n minus m natural numbers. In this video we are going to solve these equations via Pythagorean triples and Pell's theorem. Thanks to Cahya Al-Kahfi for asking the questions. If you want to try, just pause or skip this video and you can check for the solutions later. Okay, first, what are we going to do is to simplify these equations into familiar equations. As we see, both sides of these equations are arithmetic series. So we can remove the sigma by using arithmetic series formula or telescopic cancellations or another way. Doesn't matter which technique you choose, all of the results must be equivalent with these equations. And next we simplify both sides, we have these equations. Then we collect the same variables into the same sides. From here, the first idea that came up into my mind was to convert these equations into Pythagorean equations. So I multiplied these equations by 2 and then add 1 into both sides. So we have Pythagorean equations. So basically, Mn is the solutions of the questions if and only if n plus 1, n to m plus 1 is Pythagorean triples. So next step is we will find all Mn such that n plus 1, n to m plus 1 is Pythagorean triples. But Pythagorean theorem says that all Pythagorean triples can be represented as this form. So, as we can see, n might play the role of x, n plus 1 play the role of y, and 2m plus 1 play the role of z. But the role of n and n plus 1 might be reversed. That means we have two cases. The first case is n is equal a square minus b square, n plus 1 is equal to ab, 2m plus 1 is equal a square plus b square. Since the value of n and n plus 1 might be reversed, so the second case is n is equal to ab, n plus 1 is equal a square minus b square, and 2m plus 1 is equal a square plus b square. Now, let's consider the first case. From these two equations, we can eliminate the variable n. So we have a square minus b square plus 1 is equal to ab. After I see this equation, the second idea that came up into my mind was to convert these equations into Pell's equations. So I collect all the variables into the same side, then add a square minus a square. So we have these equations, which is Pell's equations. The following Pell's theorem gives us the closed form of all positive integer solutions of Pell's equations as long as we can find the minimum solutions of Pell equations. In our case, we can try to put several couples of smallest natural numbers to get the minimum solutions. The smallest one is b plus a is equal 3 and a is equal 2. So, by Pell's theorem, all value of AB are AIBI, which satisfy this following yellow formula. Using fact that 3 plus 2 square root of 2 is equal square root of 2 plus 1 square, and 3 minus 2 square root of 2 is equal square root of 2 minus 1 square, so we have these values. Moving AI to the right side, then substitute the value of AI. Then we combine the same terms and then simplify each terms inside the bracket. So we have this value. Since n is equal a square minus b square and m is equal a square plus b square minus 1 over 2, we have ni is equal this value. Again, combine the same terms and then simplify each terms inside the bracket. We have this value. Also, the value of mi is equal this quantity. Again, combine the same terms and then simplify each terms inside the bracket. We have this simple value of mi. Until here, we have the value of mn in forms of mi and I for the first case. For the second case, we can find the value of mi and I in similar way. So, I will just present the second case with the following animation. Okay guys, that's all. Next, we just need to make a simple conclusions from what we have done. From first and second case, all the solutions can be represented as mi and I, which the values are inside the boxes. The difference between these two boxes are only on these powers. But we can combine these powers into a single pattern. That is 2i plus 1. So, all these solutions can be represented into these simple conclusions. And that ends these presentations. So, thank you for watching. See you on the next videos only on Solve in Silence. Bye bye.